So we can show a line segment by using this notation. The length of a line, we have AB, and we put a little hat. This means the length from point A to point B. So if I have 2 points, you can find the midpoint by using this equation. Today we're going to develop what is the equation for the length of the line. I want to find from here and in here. All right, let's think about this. So on a graph paper, we have my x-axis and y-axis. You have 2 points, point A and point B. We can call point A as x1, y1. And point B is x2, y2. I want to go from this point to this point, and I want to find the distance. We can actually do this from something that we already know. And again, we have to find the distance from here to here. We need to find the change in my x value. Okay? You need to find the change in your x value, and you need to find the change of your y value. You need to find delta y. Now, delta y is equal to the difference. It's equal to y2 minus y1. Okay? And delta x is equal to x2 minus x1. So I can find the difference right here. I can find the length of this and this. What you will notice is this will make a right angle triangle. And if I know the base and the height of a right angle triangle, you can actually find the hypotenuse by using Pythagoras' theorem. Pythagoras' theorem says that the distance squared will be equal to the legs of the triangle squared, a squared plus b squared. This is Pythagoras' theorem. So then using this equation, the distance squared, a is equal to delta x squared plus delta y squared. And we know that delta x is equal to the difference of your two x values. It's going to be x2 minus x1 squared plus y2 minus y1 squared. We just want to find the distance, so it's going to be the square root. So the distance of a line segment is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. I want you to put a box, and this is the equation for the distance of a line. And we can use this as a formula to find between any 2 points. I can find the distance between them. And that could be useful on a grid. Let's have a, how could this be useful is, let's say we have a map. And the map is like a grid format, right? And I can have some locations. Maybe this is me. And I can have some locations right here. I could have 2 points. I could have A and B. And I want to know what point is closer. So if I want to find the point that is closer, You can find that by using this equation. If I know this location, I'm located at 1, 1, okay? I'm located at 1, 1. B is located at 1, 2, 3, 4, 5, 6, 6, 2. And A is located at 1, 2, 3, 4, 4, 1, 2, 3, 4, 4, 4. And I want to know which one has the shortest distance, let's say. Okay, we can find out these dA and dB. And we can use the equation to do that. So we're all going from here. So this will be your starting x. This will be your x1, y1. So let's find the distance from here to here. So the distance, we're going to call this point here C. The distance between CA, the length of that line, is going to be equal to the square root of x2. So this is my x2. It'd be 4 minus x1 squared plus 4 minus this y1 here, 1 squared. So it'd be 3 squared plus that square root. Nick, what do we get there? What is the distance between CA? And then we can find the distance between CB. The distance between CB is going to be the square root of, this will be your x2, so it'll be 6 minus 1 squared plus 2 minus 1 squared. Jenny, what do we get here? Okay, Nick, can you put this in your calculator? So we have 9 plus 9 square root of 9 plus 9, what do we get? Nick? Can you use your calculator? What is the answer for between CB? And then Jenny, what is the distance between this one right here? Can you put this in your calculator? What do we get? You guys can all be doing it. Nick, what is the square root of 18? So you can use an online calculator, or if you have, I would encourage you guys to have your own. If you have your own, it'll be a lot faster. You see, I just plug it in. I don't have to worry about my computer not having power or what have you. So we get here 4.24.
5.1.
And this one we get 5.1. So which one is closer, A or B? Therefore, what point is closer, A or B? This has a smaller distance, so point A is closer to me. Okay, there we go. So that's the idea. We can use the distance to find the distance, and we can determine if something's farther away from me or closer to me on a grid kind of system.